Okay, sorry I didn't get this video going quite as quickly as I had hoped or I had planned, but here it is nonetheless. It's not very long, and there's only one of them. So I'll just start the um, first topic. You will need to know the domains and ranges of all of the inverse trig functions. Um, and remember that the domain that we restrict is that of the parent function. For instance, for cosine, we restrict the domain to 0 to pi, and for and for secant, the same thing, from 0 to pi. And for sine, cosecant, tangent, and cotangent, we restrict or actually sine, cosecant, tangent, we restrict the domain of those to negative pi over 2 to pi over 2. So those are two parts, two halves of the unit circle, and you'll want to look at your unit circle and compare to these to understand um, which angles fit in the domain and therefore the range of these inverse functions. Now, the domains of the inverse functions are the range of the parent functions. Excuse me. So cosine and sine are in between -1 and 1, and cosecant and secant are above 1 or less than -1, and the inverse tangent and inverse cotangent domains are all real numbers. All right, so you will need to understand the principle, uh, and that should keep you from having to memorize, but if it's easier to memorize, then just memorize this table. Okay, now, next topic is you want to know how to determine the exact values of composed functions containing inverse functions. And that is found in the section 8.1 slides. And I believe that I've got those, I posted those in the file section on Canvas, and they are dated July 3rd and 5th, like you see down here. So there are examples of those there that you can look at and review, since if you were in class, we worked those out in class. Now, the next topic is to know how to calculate the inverse of a trigonometric function. Now, this is calculating the inverse exactly the same way we did in, I guess it was chapter 6? Yes, before we did the exponential and logarithmic functions. You interchange x and y, and you solve for y, and then you substitute f inverse in for y. The domains and ranges are determined by, so you look at the range. It's easiest to look at the range of one function. That tells you the domain of the other, and vice versa. Those are the easiest ways to go about doing that. Now, the next topic is to know how to solve trigonometric equations. There are examples in the 8.3 slides. And remember that we would express all trigonometric functions in the equation as the same type. And we had an example, I think, where we had cotangent squared on one side of the equation and tangent on the other. And you can't turn tangent into can't successfully turn tangent into an expression in terms of cotangent in such a way that that equation is easily solved. Instead, you have to use the Pythagorean identity to change cotangent squared into, I guess it's cosecant squared minus 1. So I think I have my identities mixed up here. But if you look at the Pythagorean identities, you'll see what I'm talking about, as well as the example that we did in class and is shown in those slides. Okay, now the next topic is you want to know how to use the graph of a triangle to determine a trigonometric function value, and then use the inverse to determine the angle in radians. Now, on the exam, this question takes the form of an application. In other words, it's a word problem. But that's really just a bit of a distraction in a way, because there are coordinates that are on the diagram, and you will use those exactly as you use the coordinates here. So what is this angle here? What is this angle theta? Well, you either determine the cosine or the sine, whichever one is appropriate, and of course cosine, don't forget, is x over r, r being a radius. And so cosine is -5, so that's our x. The radius is calculated here. It's the square root of this distance squared plus this distance squared, and so that's 2 squared is 4, 5 squared is 25, 25 4 is 29, so this is square root of 29. So that is the length of this radius, square root of 29. And we could rationalize here, but what we're really after is the decimal approximation. So you get the decimal approximation, and then you put that into your inverse cosine function to to see the measure of this angle in radians is about 2.76. Now, we used cosine in this example because the angle is greater than pi over 2. And that's not in the restricted domain of sine. Remember, to invert the restricted domain of sine is from negative pi over 2 up to pi over 2. So you want to keep in mind where your angle is. You want to keep in mind where your angle is to decide, do you use inverse cosine or inverse sine? And then the last topic is just which trigonometric identities you need to memorize. Now, you will notice that this is, or I hope you will notice that this is an abridged or edited. It's pared down. It's a shorter version of the identities that the identity sheet that I gave you, but that's because you won't use any of the ones that I deleted. You won't need them for the exam. Now, we should know the quotient and reciprocal identities without having to think about it. And the Pythagorean identities, which even though you might have to think about them, they should be easy enough to memorize. These, and they're very important to know as well, right now in this class and in classes going forward. And then the odd-even identities, if you just sketch one period or half a period of these functions, one period, I guess, from the negative to the positive side, say negative pi to pi or something like that, then you should be able to easily recall these identities. Now, the sum and difference identities follow a pattern: cosine, cosine, alpha, beta, and they're always listed alphabetically. Alpha plus beta, that's cosine alpha, cosine beta, minus, so this is plus, this is minus, sine alpha, sine beta. Okay, and then I'll just leave the rest for you to memorize. But there's a pattern, and they're easy, I think, to commit to memory. And then we have this property that this is basically saying that these two functions, sine and cosine, are really the same function, just shifted pi over 2 one direction or the other, which was an exam question last time. Then we have the double and half angle identities. There were other identities involving the double angle for cosine, but they were nothing more than algebraic rearrangements of these. So if you have these memorized, then that should be all you need. And there's one tangent double angle here. Notice I don't have the half angle for tangent, and don't forget that the plus minus here is dictated by whatever quadrant the angle divided by 2 is. What quadrant the half angle is. So that, for instance, if we had an angle of 150, well, 150 divided by 2 is 75. So that's going to be over in the first quadrant. So that will be positive both cosine and sine. Okay, that's all I really have to say. I don't think that there's much else to say that the slides don't cover and that your notes don't cover. But one of the slides at the end says, good luck, and if you have questions, here's my number.